In this module, we're going to give an example of how confounding can affect a genomics data analysis. We're going to use data from a paper that had as one of the results that if you compared two ethnic groups in their gene expression, they had thousands of genes differentially expressed. A very large percentage of genes were differentially expressed. We downloaded this data and performed the analysis ourselves, and in fact, we did find the same thing. Here is a histogram of p-values on the left and a volcano plot on the right, and you can see that if we, just by eye, we can see that perhaps something like 70% of genes would be called differentially expressed even after adjusting for multiple comparison. And we can see on the volcano plot that it's not, the effect sizes are pretty large in some cases as well. So it's a very striking result. I think we would expect there to be so many differences between two ethnic groups. I mean, at the end of the day, we're both humans, and that this is quite a dramatic difference. So if you look at the data a little bit more closely, and you extract the dates from the files that have the data, something that you will learn to do in the labs, and by looking at the code for this lecture, you'll see that the two ethnic groups are confounded with year. So this ethnic group over here had most of the data was processed 2004 and before, and the second one, and this other ethnic group, had most of it processed 2005 and after that. So just like we saw in the previous module, a confounded variable can make things seem more different than they really are. And they can even make it seem different when they're really not different. The same can happen with genomics data. It's pretty much the same phenomenon. So to show this, how this can happen, we're going to take two batches. We're going to define them as batches. We're going to take October 2005 and compare it to June 2005. And we're going to stick to one ethnic group. So we're not going to have the two. We're just going to have one of them. And we're going to do the same analysis. So when we do this analysis, the only difference is the date. And when we compare genes from one batch to the other, we again get many, many differentially expressed genes. So now the question is, when we saw the differences between the ethnic groups, we know that that includes a date effect. We know it. There could also include an ethnic background effect. But what we do know for sure is that it does include a date effect. So how do we parse those two out? In this case, the experimental design was such that the data was pretty much completely confounded. There's like one or two exceptions of samples from the two ethnic groups that were run in the same batch. But overall, they were very confounded. In this case, it's almost impossible to separate the two. Next module, we're going to take a subset of this data set to show how we can adjust for batch effects and find signal that has been corrected for it.